All right, our next recording that we're going to do next part of the lesson is on sine formula. This will go a lot quicker because it's really not new information. The only difference is the formula has changed. So if I ask you to find the sum or difference of, a formula involving sine, notice that now when I do sine of u plus v, my trig is different in the formula. This is sine times cosine. And now my sines actually match in the formula, and then it's cosine times sine. They're in a specific order, so make sure you notice that order. Use the formula, rewrite them, substitute just like we have. So again, we're back to these ugly fraction problems. 23 pi over 12. This is probably going to be an addition, right? Two things that add up to 23. I'm going to choose 20 and 3. Okay, so as a class, let's all do the same addition problem. And when I do that, what does unit circle values do those reduce to? 20 over 12 reduces to 5 pi over 3, and 3 pi over 12 reduces to pi over 4, both of which are unit circle values. This is one of those other places where you and the person next to you may not choose the same things to add together or subtract. So this becomes my u, this becomes my v. I go up to the formula and I need the sine of 5 pi over 3, cosine of pi over 4. Because I'm adding, I stay across the top, plus sign, and then I plug in all of the rest. So I'll let you write and get caught up. Coming up with the addition, you generate that. Formula, straight from what you're given. Now you need to use your unit circle values to plug in. Right, I will do this for you for the sake of time. So the sine at 5 pi over 3, which is the y value, is negative root 3 over 2. We're right back in it with the adding and subtracting, fraction simplification, and I get that final answer. Good question. I'll get back to you. I didn't write it. No, I mean, they've been around for forever, so.
Yeah, I know, but it's like, and like these are like some of them are ancient.
Yeah. Well, I mean, if you think about it, they didn't have calculators back in the day, so they were probably just drawing a bunch of triangles. Oh, can you believe this relationship? And then they proved it over and over and over and became like a theorem, definition, formula. Right? All right. We did one like this before. Let me make sure this is up on the screen here fully. Find cosecant of x minus y. Again, we don't have a formula for cosecant. We know that cosecant is going to go back to sine. So from the 2 units ago, we know that the cosecant of x is equal to 1 over the sine of x. Right? So we can expand that and say the cosecant of x minus y is going to equal 1 over the sine of x minus y. Look at it a little bit differently this time, since before we were reacquainting ourselves with this definition. Now we're going to apply it again. Did I give you unit circle values? No. So 2 things to consider to keep in your short-term memory is, first of all, we're going to need triangles drawn in the coordinate plane, so watch your signs, SIGN signs. And the second thing we want to think about, which just fell out of my head but is still important, is that you're going to have a fraction, 1 over sign, that you're going to do a whole lot of work in the denominator, and then you're going to have to reciprocal it. So if I take a look, here are my 2 triangles. You can sketch those, please. So my X triangle is quadrant 4. My Y triangle is quadrant 1. Since my formula is the sine formula, I'm going to need the sine of x and the cosine of x and the sine of y and the cosine of y. So notice our old friend is back. What goes with 7 blank 25? That is another special right triangle. Anybody? (625 minus 49 square roots) 24. That is another special right triangle, 7, 24, 25. It is positive because x is going to the right. And again, we have our old friend 3, 4, 5. Okay. So down here in the bottom, the sine of x is going to be -7 over 25. The cosine of x is 24 over 25. The sine of y here is 4 over 5, and the cosine is 3 over 5. You notice I have it at the bottom and I have it at the top of the next screen. This cosecant formula is what I have here substituted in for the x and y values. I then take those numbers, put them into the fraction. It looks like this. And where do I go from here? I have to do all the math in the bottom, right? So what do I get? 1 over what? -21 over 125 minus, what is that? 16, 196? 98? Wasn't it 96? Over 125? So I get 1 over what fraction? -117 over 125, which then I can reciprocal to be -125 over 117. Do you all agree? Do we have any mistakes? So real quickly, how many of you like the first type, like example 5? You think those are easier? You just want to do unit circle values and be done. How many like the second type? You like the triangles and the concrete numbers? Okay, and some people don't like any of it. Perfect. That's exactly where we should be right now. All right, sine, cosine. What do you think the last formula is going to be? Probably tangent, right? Okay, please be careful with the tangent formula. The signs are not jacked up. If I decide, like in this problem, I went with the plus, that means I'm going to use a plus, which is the top, a plus, which is the top here, and a minus, because they're all the top signs. Right? I chose to use pi over 6 plus pi over 4. Does anyone have a question how those add up to 5 pi over 12?
Some question about that, but will it always be over 12?
A lot of them. A lot of them. Could be over an 8 too. You could be using 4s and 2s, things like that. Pretty common ones though. Okay. So my question to you as a class was, are we okay with this? Yes. Awesome. Next step, go to the formula and plug it in. So now I'm going to use u plus v, so u plus v, and I substitute in where pi over 6 is u and pi over 4 is v. Some of you are already at this step. So now, this is a little bit tricky, but pi over 6, if you remember, is here. This is pi over 6. So isn't that going to be 1/2 over root 3 over 2? Which is where I'm getting the root 3 over 3. So you may want to do that tangent calculation off to the side somewhere and just say the tangent of x is root 3 over 3. Like the tangent of pi over 6 is root 3 over 3, and the tangent of pi over 4 equals 1. Just that way you don't have to hold it in your head and recalculate it every time. You write it down, you just plug it right into the formula. But notice, this is the only thing about tangent. Now we really have a complex fraction. We have fractions in the numerator, we have fractions in the denominator, correct? Does anyone have a question about the algebra that they're seeing with the fractions? Now, way back when, I taught you a technique called superfraction. Superfraction says this. I'm going to talk about it right here. This has a denominator of 3. This is a denominator of 1, 1, and 3. 3, 1, 1, 3. If these are my 4 denominators, what is the ultimate LCD of all 4 of those? 3. So I am going to multiply all of the numerator by 3 and all of the denominator by 3. When I'm distributing, this is my final answer. Notice it got rid of all of my fractions. Right, tiny. We're not done. This is where superfraction really is your friend. Questions? Anything? How did I? Why did I? Can you explain? All right, so what do I need to do next? Especially since I told you we're not done. Rationalize. You're right. So if I rationalize this, means I'm going to multiply top and bottom by the conjugate of this. The conjugate is just the sign change. None of the numbers change, like the actual placeholder numbers. Don't forget to FOIL. And if you do that correctly, you're going to go to here, then you can reduce, and then you get your final answer. example is going to be just like the other ones that we've done. Taking our tangent formula, we're going to set up right triangles in the coordinate plane. But cotangent is really the interesting part of this. So I guess I'm going to just put all this up here. Well, hang on a second. Boom, 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 and boom. Does all of this make sense to you? Like the process of it? Jumping right in, taking the first piece of information here, putting it in, doing Pythagorean theorem, telling me what tangent is. Why am I solving for tangent, not sine and cosine? Because my formula requires tangent. Taking the second piece of information, drawing it in the coordinate plane, labeling the sides, watching your signs, SIGN signs, coming up with the tangent there. The reason why we give this to you as an example is because the formula says tangent. What did I ask you to find? I asked you to find cotangent. So cotangent, just like the ones we've done before, is going to be 1 over tangent. So now I'm following the minus signs. Are the minus signs in the top or the bottom? Here. Bottom, bottom, bottom. So when I look at my next slide here, these match. I've got the sign flip there. And then I just do the reciprocal. Notice my reciprocal doesn't do anything but take this bottom part, move it up top. This now moves to the bottom. Here's the information from the last slide. I can plug it in, annoying as it is. And get my final answer.